Good morning, everyone. Today we're going to start conditional probability. Now, again, with these lessons, if we were in the classroom together, I usually start off with sort of silly examples that we can sort of all relate to and understand to get an understanding of the concept. And then we move to test-worthy examples. So I'm going to pretend, and again, if you could write this down, it would be helpful, that we've got 25 students in class today, 15 females and 10 males. Of those 15 females, 10 of them like chocolate ice cream, 3 of them like vanilla ice cream, 2 of them like strawberry, so 15. Of the 10 males, 3 like chocolate ice cream, 5 like vanilla ice cream, and 2 like strawberry. So take a moment, let's get that down. We're going to use the information to fill in the chart below, and then we're going to start exploring conditional probability. Okie doke? Okay, so how many males did we say like chocolate ice cream? 3. How many males did we say like vanilla? We're guessing, 5. And how many males like strawberry? Okay. How many females did we say like chocolate? 10. How many females like vanilla? And how many females like strawberry? So I'm just extracting the information and we're putting it in a chart. Okay. If a student is chosen at random from the class, what is the probability that he or she likes chocolate ice cream? So we are quite familiar with when we're doing a probability question, we write down what's being looked for, we write down a blank fraction, we take a look at our NS, the total, and the total is 25. There were 25 kids in class that particular day. And how many of them in total like chocolate ice cream? 3 guys and 10 girls. What is the probability that we're going to find a student chosen at random that likes strawberry? Again, 25 kids in the class. How many in total like strawberry? 2 guys, 2 girls. What is the probability that you have a male student that likes strawberry ice cream? This is the and situation. They're male and like strawberry. So out of the 25 people, how many males like strawberry ice cream? 2 of them. So absolutely nothing new at this point, okay? This is kind of similar to the dice chart type of scenario, the Venn type of scenario, because we have a chart that we're extracting the information. 13 people in total like chocolate, 4 people in total like strawberry, 2 people are male and like strawberry. Okay, let's keep going. If a female student is chosen at random, so now what's happening is I'm not looking at the entire class. I'm just looking at the group of females. And remember, we had 10 males in total and 15 females in total. What is the probability that she likes chocolate? So let me show you something because this is going to have a tad bit different notation. Probability of liking chocolate, given that we're only looking at the females. So notice this notation, probability of liking chocolate, given that we're only looking at the females. So if I'm only looking at the females, the bottom number is not 25, the bottom number is 15. And if I'm looking at how many females and they like chocolate, that's 10. If a female is chosen at random, what is the probability that they like vanilla ice cream, given that they're a female? So females in total, your NS is not your 25. It's like you're subdividing the population. You're subdividing the population into females and males. And of those females, how many like vanilla? This is what we call the classic conditional probability, because a condition is being put on, and the condition right here is the issue of being a female. You're not looking at the entire population. You're subdividing the population and then calculating a probability. So hold on, let's read this last little blurb. For these questions, the NS has changed because we're only looking at females. We have to put a condition on the probability. And the whole idea is that the NS changes from that classic 25. Okay, let's flip when you're ready. I'm just going to leave the top information visible because we're still dealing with some ice cream. If you're a vanilla loving student, vanilla lovers, that's a total of 8. What is the probability of being a male? What is the probability of being a male given that you're a vanilla lover? Well, vanilla lovers are 8. Of those 8 people that are vanilla lovers, 5 of them are male. What is the probability of being a female given that you're a vanilla lover? Again, vanilla lovers are 8. Let's think about this. Chocolate lovers were 13, vanilla lovers were 8, and strawberry lovers were 4. Again, adding up to the 25. If you're a vanilla lover, what's the probability that you're female? Again, conditional probability because your NS is changing. You're not looking at all 25 people. You're subdividing the 25 people into chocolate lovers, vanilla lovers, strawberry lovers. Okay, let's keep reading. It says, again, this is a conditional probability. Conditional probabilities are all about looking at the probability of an event happening if you know something about the outcome. So what you know is that you're only looking at vanilla lovers, or you're only looking at females. The probability of event A occurring given the probability of event B is in this particular formula right here. So let's take a look at what the formula stands for. Probability of A given B is the outcomes of A and B. So think about it here. Males and vanilla lovers. Females and vanilla lovers. Over outcome of B. And again, this formula will definitely need to be memorized, right? Okay. Let's move away from sort of silly examples and let's kind of get into more test-worthy, assignment-worthy types of questions. Okie doke? What is the probability of drawing a queen? Very easy. We know there's 52 cards in the deck. We know 4 of them are queens, 1 out of 13. What is the probability of drawing a queen, knowing that you only are dealing with face cards? So this is conditional because it says to you, you're not dealing with the whole deck. You're dealing only with the face cards. So your NS has changed from a 52 to a 12. And the number of queens in the face card are again 4, 1/3. Now, with anything in these particular units, there are words that indicate conditional. And let me give you some ideas. Given that, obviously, is one. Knowing is another. Sometimes if, but I want to warn you about if. If is one of those words. It could be conditional. It might not be conditional. Okay. Let's keep going. Well, another classic example for conditional can come from the dice chart. So let's take a moment and fill in our dice chart. Remember, I said to you that you're going to have to know how to fill in the dice chart for yourself. Beautiful. Dice chart filled in. Okay. If you're rolling 2 dice, what is the probability of rolling a sum greater than 6? So we know that when we're working with a dice chart that your NS is 36. Excuse me. Excuse me. And a sum greater than 6 would be all those green options right there. Greater than 6. Let me add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 out of 36. This isn't conditional. This is a straightforward dice chart question because your NS is your total standard NS. Let's keep going. If you're rolling 2 dice, what is the probability that the sum is greater than 6, given that the first die is a 4? So right away, the words given that tell me that this is going to be conditional and it's not going to have a denominator of 36. Now, let's talk about what they mean by the first dice is a 4. Let's say that I have a dice and you have a dice, and we're about to throw them on the table. Mine actually drops out of my hand and it hits the table first. And it ends up a 4. So the first dice to hit the table is a 4. Your die then hits the table. It might be a 1. It might be a 2. It might be a 3. It might also be a 4. It might be a 5. Or it might be a 6. So if the first dice is a 4, then there are 6 different options with however the second dice rolls. Now, of those 6 options, what are the sums? Well, 4 and 1 is 5. 4 and 2 is 6. 4 and 3 is 7. 4 and 4 is 8. 4 and 5 is 9. 4 and 6 is 10. Of those 6, how many of them have a sum greater than 6? Beautiful conditional. This is very much a classic conditional. We can put a star beside that one. Okay, let's keep going. Multiplication law for conditional probability or selections. Conditional probability and selections, they actually go hand in hand. So if you've had some experience with a selection question and you got your 3 fractions and your denominator in your second fraction is changing and your denominator in your third fraction, this is classic conditional. It's a meshing of the 2 concepts. It's meshing conditional and selection. So let's put a star beside this. It's a fantastic question. And let's take a look at what's happening. A bag contains the letters of the word shore, S-H-O-R-E. And you guys are familiar with the bag with the letters in it, right? An S, an H, an O, an R, and an E. What is the probability of selecting a vowel? Well, the assumption is when they were selecting a vowel that the hand is only going into the bag once. So letters are in bag, hand goes in bag, swish, swish, swish. How many letters do I feel in the bottom of the bag? That's my NS. How many of those letters are vowels? 2 of them. Nothing conditional about that. Okay, let's take a look at the next one. Selecting 2 letters in a row. So now the assumption is hand goes in the bag, makes a selection, hand goes in the bag, makes a selection. And getting 2 vowels. Okay, so let me show you how you set up a selection question. Here's my first selection. I'm looking for a vowel. Here's my, here's my second selection. I'm looking for a vowel. Now, keep reading just for a second. Do not replace the letter after the first selection. So hold on. Letters are in the bag. Hand goes in the bag. How many blocks do I feel? 5. How many of them are vowels? Yay, I ended up with the E. I put it on my desk. Hand goes back in the bag. How many blocks do I feel? 4 of them now, because I didn't put the block in. I'm displaying it right on my desk. How many of them are vowels? If I got a vowel on the first one? 1. Very, very, very classic selection question. Okay. Need to kind of look at these guys. Okay, some of them are gonna be a bit tricky. Trust me on this. Okay, let's keep going. What is the probability of drawing? Now, I want to stop for a moment because when I introduced you to selecting, we said the word selecting could be used. We said the word drawing could be used. And we also said the word pick could be used. So what is the probability of drawing a face card and then an ace? Do not replace the cards after the first selection. So envision me fanning the cards out in front of you. You have 52 cards fanned out in front of you. 12 of them are face cards. Yay, you got a Queen of Hearts. You put it in your pocket. I then fan the cards out again. Now you have 51 cards fanned out in front of you because one of them's in your pocket and 4 of them are aces. Beautiful probability of 4 over 221. So the whole idea of selection and conditional, as soon as this bottom number changes, It's a selection question, but it's also conditional because your NS is changing. So they really go hand in hand with each other. Okay, last example. Okay. The probability that Jody will go to Western is 1/5. If Jody goes to Western, the probability that her boyfriend Craig will go is 3/4. What is the probability that both Jody and Craig go to Western? Now, I chose this example specifically because it requires you to use the formula, and I would actually expect that if I were you guys. Okay, I would actually expect that. So hold on, let's take our formula and put it into Jody's and Craig's. So what is the probability that both Jody and Craig end up at Western? That's this right here, the Jody and Craig. Now, that's going to say to us, what is the probability that Craig ends up at Western given that Jody's going? Right? Let's take a look at that just one more time. The probability that Jody will go to Western is 1/5. If Jody goes to Western, the probability that Craig will go is 3/4. What's the probability that they both go? So what we're looking for is we're looking for this. Let's fill in the numbers though. Probability that Jody's going is 1/5. Probability that Craig goes if Jody goes is 3/4. Now I can do a beautiful cross multiplication. And I can say that the chances of Jody and Craig both going is 3/20 or 15%. So please do me a favor. I don't want you to discount the formula because there's always those types of questions that pop up that require you to understand the conditional, the and the given that. Given that Jody goes, what's the probability of Jody and Craig both ending up there? Given that if Jody goes, Craig is also going. Okay, these take a little bit of work. Make sure to give them a go. There's definitely one on your conditional probability handout to play around with. Okay, thank you.